And I'm going to go to the slide, chapter 6. Y'all should be able to see it. Tell me if you don't. Well, Miss Carver, chat if you don't. All right, where did my Skype go? There we go. And let's go down to NPX. You're going to like this because this is not very difficult. There we go. All right, slideshow and correct slide. All right, now before I go into this, I want to remind everybody what we've went over so far, because right about now y'all get a little bit confused on what we're doing. Okay, so I'm going to just write a few things down. In 6.1, we talked about a probability distribution. And that's where we had a chart and the event and the probability of the event 0, 1, 2, 3, and 0.1, 0.2, 0.4. Let's see, that's 0.7 and 0.3. And then we were able to find the mean and the standard deviation based on that. Remember, the mean was the summation of E times P of E. Okay, remember we did that? Or X times P of X. It might have been written like that. I can't remember. X times P of X. Now we went through and we multiplied this by this and then added them all up. And then the standard deviation was the summation of x squared times P of X minus mu squared. Y'all remember doing that? Square root of that? Okay, that was 6.1. And then 6.2, we started talking about NPX, and that was just finding the probability of X. And I told y'all that if you flipped a coin 50 times and there was a 0.3 probability that it comes up heads, what would be the probability if it come up heads the next 10 times? Okay, and then you would type in NPX. We talked about binomial PDF. PDF is exact. That's exact. And then binomial CDF is cumulative from the left. Okay, we talked about that, and then we talked about the complement. Okay, I'm trying to think. I was going to ask you something, Miss Carver, but I can't remember what I was going to ask you. Okay, I'll figure it out in just a minute. And now we're going to find the mean and the standard deviation of NPX. Okay, now we're going to find the mean and the standard deviation. So there's three types of questions that I'm going to ask you on this test. The first question will be find the mean and the standard deviation of a probability distribution. Oh yeah, Miss Carver, is the lag a little bit better today? Just say, you know, if it's better or not. I appreciate it. I think it's getting better. I'm looking to see what you're going to type. It is better, but it's still there. Well, I think it always will be there because I don't know where you're, Mr. Brooks. Where are you Skyping from?
I'm Skyping from Easley.
Easily. And Miss Carver,
Yeah.
where are you at? Okay, I'm right beside West Side. Well, you should be getting it closer. Your lag should be less than me. Oh well. Okay, well, I don't, or less than Mr. Carver. Mr. Brooks, do you have a lag when
Yeah, I
I'm
do.
writing? Huh?
Yeah, I do. It's not that bad when you watch the YouTube videos though.
Okay, good. I'm glad you told me that because I was worried about that. Okay, well, that's because I'm recording from my desktop and it's not transmitting out to y'all. It's just recording from my laptop. Okay, well, I just wanted to know that. All right, so the first question would be this type question. The second would be an NPX, binomial PDF, and binomial CDF. And now we're going into the last part of 6, which is real simple math. Look at there. NP and NPQ. Remember, I don't use 1 minus P. Okay? I don't use that. I use Q. So you can write that as the mean is equal to NP and the standard deviation is equal to NPQ square root. So that means the variance is equal to NPQ. Now while you're writing that down, I'm going to write it down on my sheet here so I already have it when I pull up the sheet. God, I'm going to have so many papers. I'm just throwing them back there behind the monitor. So mu of NPX is equal to N times P. The variance is equal to NPQ, and then the standard deviation is equal to the square root of the variance, which is the square root of NPQ. All right, so do y'all have that written down? I'll go with Mr. Brooks because I'm sure that Mr. Brooks' delay is probably more than Miss Carver's. So, Mr. Brooks, do you have that written down?
Yeah, I've got it.
Okay. Miss Carver, you just say go back whenever you want me to go back, okay? So here is, this is the same type problem, except I want you to notice the definition. I mean, not the definition. I want you to write down the directions. Because the directions tell you whether you use NPX or whether you use NP. The directions are asking you for the what? The mean and the standard deviation. So in this case, I'm going to write it down, and then we're going to go to it on the Word document. Document cam, sorry. So here we got P is equal to 0.35, and N, that means Q, is equal to 0.65, and N is equal to 400. And the directions say, find the mean and the what? Standard deviation. Okay, so it's very important, and I'm saying this 2 or 3 times because when other people in the class watch this video, they'll get mixed up and say, well, how do I know whether to use NPX or well, NPX will say find the probability. NP will say find the mean and the standard deviation. Simple as that. So I'm going to go to my handy dandy. I wish I could switch back and forth without having to go through all this, but I'm glad I got what I got. If it hadn't been for me buying this stuff, I wouldn't have it at home. Oh, I wanted to mention something. Do y'all remember me sending y'all an email about Teams, Microsoft Teams? Yes or no? I guess not. Okay. Teams is basically made by Microsoft, and it is the same thing as Skype for Business. I think it's an upgrade. I teamed somebody this morning. Okay, you remember, good. You remember the email. I teamed somebody this morning at Tech, And basically what has happened is the faculty and staff can log on to Teams, but the students cannot. And I think that's because, personally, I think it's because somebody dropped the ball and said, well, students don't use Skype for Business anyway, so we ain't going to worry about it. Okay? And they didn't dump the names into the Outlook or the Teams, whatever, to log in. So that's why you can't log in. Miss Carver, have you tried to log in? I see you typing something. Yes, when I tried to log in, it never let me. See, I logged in today, and I actually called somebody, and when I tried to call, let's say Miss Carver, C-A-R-V-E-R, there's you. It won't pull you up. It'll say you're offline because you either haven't downloaded it or you have downloaded it but you haven't logged on. And we are working on that. I emailed the IT department this morning and said, what's up with this? I called 2 people this morning on Teams and had no problem, but the students can't use it. Somebody needs to fix this. So I will keep y'all up to date on that because Microsoft is phasing Skype for Business out because I think they personally have upgraded it, and it worked fine. It was very easy to use. And if you look, there's 2 teachers right there that's got it. So they can log on to it, but the students can't. So we're checking on that, and I'll keep y'all up to date on that. Okay? Because if I don't think anybody on this campus will. So anyway, so here is the problem. Let's go back to I'm trying to get there. Go back to our handy dandy document, DocCam, whatever, and basically just plug and chug. So remember, the directions will say mean and standard deviation. So the mean is equal to 0.35 times 400. The variance is equal to 0.35 times 400 times 0.65. And the standard deviation is equal to the square root of the variance. So I'm going to pull up my handy dandy calculator now, just because I want to use it. And clear. And that's 0.35 times 400. So the mean is equal to 140. Now I'm going to multiply that by 0.65. And that is my variance. Variance is equal to 91. And then take the square root of 91, raise it to the 0.5 power. I got 9.5. And that's how you find the mean, the variance, and the standard deviation of a binomial distribution, NPX. Now, I'm not going to spend a lot of time on this because that's pretty simple, okay? And I think this is the last. They do some charting, but I don't even care about that. All I want you to be able to do is find the mean, the variance, and the standard deviation. And if you can do those 3 things, you can pass my test and as far as my homework, okay? That takes care of MPQ. And I think that's all they got. Let's see. Okay, 140 and 9.5. So we got that right? Yeah, they want you to graph it, and I don't really understand why they're doing this, so I'm gonna worry about that later. Let's go to chapter 7. Chapter 7, I'm just going to draw on this for right now. Chapter 7, we're talking about area under a curve. Okay? Chapter 7, and I will tell you right now there's going to be a lot of questions on Chapter 7 on this test. Area under a curve. Now this is not calculus. I could actually show you how to do the derivative, antiderivative. Area under a curve. But this is statistics, so it's a whole lot less complicated. Area under the curve, area under all these curves is going to equal the probability of 1. So the area under the normal curve is 1. The area under the uniform curve is 1. There's two types. There is the normal curve, which we have been drawing since the first week of class. And remember what I told you. Go to Google, pull it up, put it on paper, run 10, 15 copies. Of course, nobody did it, but 0, 1, 2, 3, -1, -2, -3. Also told you to include the empirical rule. And of course, on Google, they have better representations of that than this. 2.35 and 0.15. And then uniform. Uniform curve is not a curve, it is a rectangle. Why is it a rectangle? Because uniform curve deals with the only thing that we cannot control. What is the only thing that we as humans cannot control? Time. Okay? So there's the two type problems. I can tell you right now on the test, you'll see 2 of these on the test, and you'll see about 8 of these. Okay? And that's just out of Chapter 7. The other 20 are going to come from Chapter 6. The other 10 problems are going to come from Chapter 6. But you're going to deal a lot with Chapter 7, the normal distribution. Okay? So how do you do a uniform? We'll do uniform first. Uniform has to deal with time. Stats teacher usually goes 60 minutes of lecture. Okay? So there you know, and this has to do with area of a rectangle is equal to base times what? Base times height. If you're wondering, I'm in the breakfast room. If you keep seeing the lights change, I've got windows and French doors around my breakfast room, and I've tried to close everything up, but the sun keeps popping in and out, and that's why it keeps changing light. So if that's why you're wondering, I know you don't care, but anyway. All right, so you got a rectangle here. And why is it a rectangle? Because this line up here is variance. Let me ask you this. Does time speed up or slow down? It doesn't. So that's why you have a straight line. That's why uniformity has to do with time, because you can't control it. It's all it does. Time does what it does. All right? So we know that this, the base, is equal to 60 minutes. We know the area is equal to 1. Now, why did I write 4 decimal places? Because I like to tell students, and write this down. I'm writing this down in red, so that means it's very important. 4 decimal places, usually in this unit, equals area. 2 decimal places usually equals z-score. All right? And that's what I try to do when I do these problems. I try to write area in terms of 4 decimal places and z-score in terms of 2. All right? So I got to find the height. So I divide by 60. And my height is equal to 1/60. So now I have a base and I have a height. Now the question will ask you, here's the question that you're going to get on the test. The question will say, what is the probability of the teacher going to or teaching up to 40 minutes? Okay, they may ask you, what is the probability that the teacher will stop after 55 minutes? Or what is the probability that the teacher, whatever the case may be. So I take my handy dandy blue pen and I go up here, up to 40 minutes. 40 minutes is right about there, right? So what is the base of this triangle? I meant rectangle. The base is 40. The height is what? 1 over 60. So area of the blue triangle, okay, the area is equal to the area of the blue triangle up to 40 minutes, or rectangle, sorry, is equal to base times what? Height. And A is equal to 40 over 60 is 4 over 6, which is 2 over 3, which is 0.6777, I think. Y'all check me. Somebody divide 2 divided by 3. Is it 7's repeating? I'll check it. 2 divided by 3. Yeah, 0.6666. Okay, 6667. There we go. 6667. So the area in this blue area is 0.6667. Tell me this. What is the area to the right of the blue area? That's the complement. So the area to the right would be 1 minus 0.6667. 1 minus 0.6667 is 0.3333. Now, this mentality of you finding the area and finding the left side and the right side is detrimental in this chapter 7. So make sure you can do the left and the right side, because that's what the questions are going to be asking. All right? Questions so far. All right, this is uniform. Now, sometimes they will give you the height. Sometimes you have to calculate the height. That'll be the 2 type questions that you get. 1, they give you the height. 2, you have to calculate the height. Okay? That's the 2 type of uniform questions. Okay, now I'm going to go to the normal questions. The normal, and let me see what time it is. I got 10:40. What time's class end? 10:55 or what? Do y'all know? 11:05. Thank you, Miss Carter's on the ball. Mr. Brooks, you ain't asleep, are you?
I can't even unmute my mic quick enough to respond quicker than her.
All right, so here's the normal. And I'm going to draw everything out because you need to. I'm going to put z-scores, 0, 1, 2, 3, -1, -2, -3. And I'm going to put my blacks have gone to a blunt, so I'm going to use the red. I don't use it very much. It's still sharp. 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, and 0.15. And that's what you should have on every drawing. Okay? So, with that being said, what do we ask for? Well, you're going to have to get the z-score on these guys. Now there's two types of questions that you're going to get on the test. One, the mean is equal to 0, the standard deviation is equal to 1. And that's what this looks like, okay? The other will be, and I'll do this in green, the other will give you a mean of 100 and a standard deviation of 20. Now, the good thing is, with the newer calculators, it doesn't matter which one. You just type in whatever the mean and the standard deviation is, and it will give you the answer. The bad thing is, if you don't have a new calculator, you have to change this into a z-score. But just for instructional purposes, I'm going to put this in green up here. So this will be 100. This will be 120, 140, 160, negative 80, I'm sorry, 80, 60, and 40. Okay, so those are the two types of questions. And you're going to have to change, you're going to have to use two formulas in this part. The first one is your z-score formula, x minus x bar over standard deviation. That's the one formula you'll use. And the other formula will be x is equal to Oz plus mu. Now, of course, after we do 5 or 6 of these examples, you'll know which one to do. But what you're doing is finding the area under the curve. If I take another color, let's go with purple. Okay? If I decide that I've got, let's say, if I put, the question may say, I've got x is equal to 115, or it may say z-score is equal to 0.75, something, okay? It may get, that's the two different types of questions, all right? And they want to find the area to the left of whatever they're asking. If it's one type question, it's going to be 115. If it's the z-type question, they'll give you a z-score. The only reason I don't want to put a z-score here is I don't know what the z-score is. Well, let's see. 115 minus 100 is 15 over 20. Somebody, what's 15 over 20? 15 divided by 20. 0.75, so that's going to be 0.75. Okay, they could give you, in the question, they could say, well, blah, blah, blah weighs 115 pounds. Okay, what is the percentile of blah, blah, blah since he weighs 115 pounds? And then you have to give this area. Or the question will say, blah, blah, blah ranks at 0.75 on the z-scale. What is the area to the left of 0.75? So it depends on what the question's asking, and that's what you do. You either change it to a z-score or you punch it in your calculator. Okay? Also, remember that your empirical rule will also give you a common sense, and like I know this is 50% right here. So this is 34. This is a third of 34. A third of 34 is what? 3 into 33 is 11. So that's 22 right there. 22 added to 50 is 70. What did I say, 22? Yeah, 72. So I think this is around 72.7200. And I did that based on the empirical rule. That is very important for you to use the empirical rule to say, okay, what does this look like? Well, it looks like about 72%. Well, how do I use that on a calculator? Well, on a calculator, I'll show you right quick. Let's get out of this. Oh, let me go back to one thing on this. Don't forget that this guy down here is called negative infinity. And this guy right here is called what? Positive infinity. Now in statistics, we cannot use negative infinity and positive infinity. So we're going to use, instead of negative infinity, we're going to use negative 9999. And for positive infinity, we're going to use 9999. So in this case, I'm going to use, I'll read from left to right. I'm going to use negative 9999 to 0.75 on the z-scale when I type in, or I'm going to type in the calculator. X is equal to 115, the mean is equal to 100, the standard deviation is equal to 20, and then it'll spit out the same thing that this will spit out. But after we go through several problems, you'll see what I'm talking about. So let's go to the handy dandy calculator, and I'm going to show you what to use. Second, bars. Second bars, I'll write this down. Second bars, and the two that you want to concentrate on is normal PDF and normal CDF. I'm going to use normal CDF because that is the one that you use with z-scores. See there? Negative 9999 to, what did I say, 0.75. And see, I can't type in the mean and the standard deviation. Do y'all see that? I can click, I can go down. It will not let me change the mean and the standard deviation. That's when the mean is 0 and the standard deviation is 1. That's when you're using z-scores. And I go down and I hit paste. Oh, I can change it. Okay, well, I'm going to leave it 0, sorry. And paste. And enter. 0.7733. So let me go back. So the area to the left in this purple area, I said it was 0.72. Well, I just eyeballed it. But the actual area is 0.72. What did we say it was? I'm sorry. What did I say? .77. Thank you, Miss Carver. Miss Carver must write down everything. 7734. 7734. 7734. Now, what if you want to change it? If you change it in the calculator, if you don't want to use the z-score, you go second, bars. We're just going to stick with normal CDF right now. And I'm going to type in lower is negative 9999. Upper is, what did I say, 115? My, got to hit enter on the calculator. Mean is 100. And my standard deviation is 20. And that's if you don't want to change it to a z-score. And you hit enter, enter, and enter, and it should be the same thing. See, it's the same thing. So whether your calculator is old or new, if it's old, you're going to have to change it into a z-score. If it's new, you can just type in whatever they give you. Question, gripe, complaint. All right, so let's look at the slides and let's see what they give us. My cats are walking around behind me. Okay. There's uniform distribution. This is an example of one where they give you the height. If you notice, the 160 is there. They give you the height. And there's the base. And there's an example here. Now here, they ask you the area between 15 and 30. Well, what's the distance between 15 and 30? 15. So you multiply 15 times 1/60th, base times height. And that gives you 0.25. Now I carry it to 4 digits, and that's because I try to discern between area and z-scores, and it kind of helps y'all get unconfused. And there's the normal curve, and here's the normal curve. There's the normal curve. I'm not going into this. Okay, empirical rule, telling you to make sure to use that. There's the empirical rule. I'm going to leave that up for a few seconds for those that want to copy it on the video. They can pause it. And that's not what I want. I'm trying to get to a problem. Okay, here we go. The weights of giraffes, and write this question down. The weights of giraffes are approximately normally distributed with a mean of 2,200 and a standard. Remember what I told y'all, when you see the mean and the standard deviation, what does that mean? Draw the damn curve. Well, that's what it means now, draw the damn curve. So I'm going to draw the curve while you are drawing it. So we got, that's why it's very important. Use the Google curve. They're going to put it on paper and run 10 or 15 copies, because you're not finished. Chapter 8, 9, and 10, we're going to be drawing pictures again. So that's going to be 2,200, and then 2,400, 2,600, 2,800, 2,000, 1,800. I hope y'all are drawing it. And 1,600. And I'm going to put in peach. I'm trying to use different colors so you can see it. This is 0, this is 1, this is 2, this is 3, -1, -2, -3. And then I'm going to do red. I'm going to do the empirical rule, 0.15. 2.35, 13.5, 34, 34, 13.5, 2.35, and 0.15. So whenever you see mean and standard deviation, it's telling you to draw the damn curve. Shade the area under the normal curve to the left of 2,100. So that's our directions. I'll write that in purple. Okay? Left of 2,100. That's our elevator music. I've got 10 minutes. Well, this is good, because if you can understand this problem, you can pretty much do chapter 7, except for one other question where they ask for you to use the other, the Oz plus mu. But anyway, I'm going to take this purple. Okay, I'm going to get out of this. I'm going to take my handy dandy. There we go. That's what y'all should have right there. And they want the left of 2,100. Left of 2,100. Well, there's 2,200. So they want the left. I'm going to do it in another color. I'm going to do it in green, because that purple looks like black. So there's 2,100 left of 2,100. And they want to know this area right there. Well, by the empirical rule, I'm going to say, let's say this is 2,200, or that's 20, oh, I'm sorry, 2,100 be in the middle. Sorry about that. 2,100 be in the middle. So then, you know, what's half of 34? 17, right? So add, this is 5, this is 2.5. 2.5, that's 16. What's 16 plus 17? 33? I think. I'm going to put up here in peach, I'm going to put, I think it's around 0.3300 by the empirical rule. Because you need to use the empirical rule to make sure you know what you're doing mathematically. Okay, so I think it's going to be around 33%. Now, what is this arrowhead called down here? This one's called negative infinity, negative 9999. This one's called positive infinity, 9999. All right, so you want the area from negative 9999 to 2100, but you got to type in 2200 and 200 in your calculator. So if you don't use the z-score, which you're going to have to use the z-score before long, you're going to have to use it. So you can't rely on your computer calculator for everything. I'm going to go back to the calculator, and I'm going to hit second bars, and I'm going to go, that don't look right, second bars. That hit something wrong. Second bars. Ooh, I did hit something wrong. There we go. Yeah. And normal CDF. And if, let's say that I'm lazy and I don't want to have to do the z-score. Then I type in negative 9999 to what? To 2100. And then I type in, I can't use my keyboard, I have to use the mouse. Then I type in, my mean is 2200, and my standard deviation is 200. And now I hit enter, enter, and enter. 0.3085. So I got in the calculator 0.3085. That is the area under the curve. Now what is the area to the right? Well, this over here would be 1 minus 0.3085, which would be, I'm just doing it, I don't want to do it in my head. 1 minus 0.3085, 6915, 0.6915. Now the question didn't ask that, but I'm trying to get you to think in terms of the complement of each other. So I said it was going to be around 33%. Oops, I'm sorry, I didn't turn on my, thank you, Miss Carver. Let me turn on my, so I said it was going to be 0.33 or 33% by the empirical rule, and it actually came out to be 31%. Now, is that bad? No. At least I know I'm in the right area. If I came up with 72%, I know I was wrong because the empirical rule says it's going to be around 33%. Question. Now, what if I didn't? And I'm going to finish this and I'm going to shut up. I got 5 minutes. Now, what if I don't have a calculator that does the z-score? Then you need to change it to a z-score. So I'm going to take my green marker and I'm going to say x minus 2200 divided by 200. And that's going to be negative what, 100? That's going to be negative 100 over 200, which is equal to negative 1/2, which is equal to negative 0.5. So there's my z-score. Not only is it 2100, but it's also z is equal to negative 0.5. And now I can go to my calculator. If I have an older calculator, and I can do the old z-score and go, I'm going to be a little bit lazy here and hit second, enter, there. And then I'm going to go backwards. And I'm going to type in negative 9999, 2, and I'm going to type in negative 0.5, and I'm just going to delete that. Hope I don't mess everything up. There we go. And then I'm going to type in my 0. It's supposed to put a, why did it put a, it's supposed to be a comma there. Where's my comma? There it is. Okay, and I'm on delete. My mean is 0, and my standard deviation is what? 1. Now, if I did everything right, it should come out the same. 0.3085. So that's how you do it if you don't have a calculator that's an older calculator. Okay? Questions? Now, except for one more question, which we'll go over Wednesday or Friday, except for one other question, you should be able to finish chapter 6, 6.1 and 6.2 and start on 7.1 homework. 7.2 homework may have some of those questions that I haven't gone over yet, and there's only one that I haven't gone over yet. So, and we'll go into that Friday. So I need you to write down this question, slide 23, 7.1, slide number 23. I know Miss Carver's going to write that down. Okay. So anyway. Y'all are done for today, and I will stop the recording.